So chapter 2-6 is all about special functions. And so special functions are, there's different types. First, we have the piecewise defined function, so pieces. This function is usually in pieces, and what determines those pieces? Well, you have two or more expressions that'll tell you what to do. So for example, any number x that is less than -1, so like -2, -3, etc., those are the numbers that you plug into this x. So y is equal to -2 minus 2, -3 minus 2, -4, etc. Then, if you have a number greater than or equal to -1, so like -1, +2, +7, +100, any number like that, greater than -1, then you plug it into this equation. So if you notice, you have these two different symbols. One's a less than, one's a greater than or equal to. So whenever you're going to graph these two, first you need to find points that are on this particular one. So what I did was I went ahead and substituted, well, what is it at -1? What does it look like, right? So I substituted in the -1 for that function. So then over here, the same thing, see what happens, right? And so at those points, remember here we see that it's greater than or equal to -1. So here's your -1 for the x. It can be equal to it, or then of course the y values that you get are going to be greater. At the same time, you've got the other case where you have this situation right here. At -1, exactly -1, your numbers are getting smaller here. And so you have a graph then that faces this way. So notice how you find first the points that are important. So what happens at these points right here? And that's exactly what I graphed. And then that way you can do the rest of it. So the domain for this particular graph, that means what x's are here. Well, if you notice, it's all the x's that go this way, and then all the x's that go that way. So essentially, this x is cut, which is a -1, by this function, even though this one can't be that point, but it's everything else this way. So it's all real numbers because it goes to positive infinity, negative infinity. But what about the range? Well, in the range is where we have something unique, and that's based on the equations that they gave us for this problem. So the range is the set of all f of x such that f of x is less than -3 or f of x is greater than or equal to 2. So, because look, there's a big gap right here. So there is nothing in between. If you notice, this is 2. It can't be equal to y1, y0, y -1, -2. It goes all the way to -3, but not equal to it. But that's why we don't have the little bar here. So just look at the equation, look at the graph, and then you can make some conjectures from the information. So basically, if they give you any problem, kind of do the steps to try to graph it. You can build a table of values, and that'll really help. Now, we do have a piecewise linear function. And what does that look like? Well, it's usually made up of a single expression, and it can just be in pieces. So you've got a piece of a line here, then it jumps up here, then maybe over here, etc. So a step function is something that looks like this. So it can have a value here, but then it goes up to here. Here it jumps up, then it equals here, and then it same thing, open value jumps up. So if you notice, kind of like this situation we had here, the jump was a lot bigger, but this one, since it's called a step function, it's almost like picture like stepping up a staircase. Then you've got another function called the greatest integer function, and it's denoted by these things. They almost look like a mix of absolute value, brackets, parentheses, whatever you want to call them. So the greatest integer function is denoted by f of x is equal to, and you call it that, the greatest integer, where this symbol, that's what it means. And it's less than or equal to the whatever the x value is. So, for example, since it's the greatest integer, think of rounding either up or down, whatever is closest to it, right? So the greatest integer, in other words, what's the greatest whole number of this thing? Well, it's closer to 3, right? So the greatest integer of 3.25 would be the number 3. What's the greatest integer of negative 4.6? Well, remember, after 4.5, you start rounding up to the next number. But remember, you go up to the greatest integer part. And so we're looking at a number that would be next to this. And 4.6 is closer already to 4.5, to 5. So therefore, you would quote, like, round it up. It's the greatest integer next to that number there. So you would round it to the negative 5. So the absolute value function is another piecewise type of function, but you have those, remember the absolute value that we did several sections before. And so one other function you have to be aware of is the parent. The parent function of the absolute value is, remember, parent, think simple, right? Like the kids, are all tattooed and they have all these, different things going on, colored hair, etc. But usually the parent's a little more calm, just simple and so on. Well, think of parent functions like that in when you're graphing. A parent function of the absolute value is like that, the absolute value of x, nothing, fancy or whatever. How do the kids come out? Oh, -7, +3, all these extra things. So the parent function is usually denoted like this with the 2 bars on its side. But look what happens when you are actually going to plug in points. So x, if x is greater than 0, so f of x is equal to x. So then, in other words, y equals x if x is greater than 0. So if x is 1, y is 1. If x is 2, y is 2. X is 3, y is 3. See, what's happening here is if x is greater than 0, so 1, 2, 3, 4, all of these numbers, then y is equal to x, because remember, f of x is like y. But what if it's 0? When f of x is equal to 0, then x also equals 0. So x is 0, y is 0. Here it is, the origin. But what if you have a negative x, like -1, -2, -3, etc.? I'm dealing with this situation, then you use this. Then whatever your number is going to be less than 0, but it turns positive, or the opposite sign. So when x is -1, I get 1. When x is -2, I get 2. When x is -3, 3, etc. And I think you see what's happening. In other words, there are no negatives. Remember, absolute value, you take just like the number, right? Like kind of the positive number of it, because it's a measure of distance. So therefore, you're going to end up with all these positive numbers, no matter which way on the x you go. The domain of this particular function is all real numbers, because check it out. It goes all the way. I mean, I could go on. Obviously, I've run out of screen. All the way positive infinity and all the way to negative infinity. And the thing about the range, check it out. It's a little bit different. It does touch the 0. That's why it's a closed bracket here. So because it does reach the 0, but then it goes off to positive infinity this way, up here for the range. Remember, range is y, which is this one right here. It does not go to the negative y's at all. So that's why you would have the domain and range a little bit different like that there. Now, let's go on to your packet. Your packet has the vocabulary, and you'll see some of those coming back up here when we look at the actual packet contents. So if you notice, slide number 10, which is here, shows you a piecewise function, and again, how to be able to identify the domain in that. So you go ahead and look at those examples. It actually graphs it for you. So what I would recommend is you try to graph it by yourself and to see how it goes. And then, of course, come back and compare your answer, because the answer is listed right here. So do what it asks you to do. What I would recommend is draw a table of values. And so to see what your equation turns out to look like because it's going to be in pieces. Then, of course, you've got some more examples that you can work on. So, as I had mentioned, I had given you some information about the absolute value function. Here we have your step function, so you can look at that. If you look at the shape of the absolute value, it looks like a V. And so remember about the domain and the range, for the domain, it's all negatives, positive, infinity, but for range, you cannot have any y's coming down here to be negative. So kind of read the information about the parent function and the things that we discussed in the notes. So now, if they want you to identify the domain and range, sometimes you just build a table. If you don't have a calculator with you, that's fine. Just go ahead and go through and build a table of values to help you figure, what it is that you need to be looking at. That way you can kind of get an idea of the actual domain, which is your X, and then your Y values, what happens to them. So in the study guide and intervention, you're going to have some practice problems, and it's just asking you to graph. We've done some of those in the examples, and you've seen some in the notes. So please just go ahead and create a little table or practice y equals x plus 2 if your x is going to be less than 0. So -1, -2, -3, you follow this rule right here. If x is between 0 and 2, or equal to them, so I would try 0, 1, 2, those are already 3 points, but plug them into this one. And if x is greater than 2, 3, 4, 5, then plug those into this one, and then create a table, go plug your values in, see what that looks like. So that's just some practice for your graphing here. And then they do talk about the greatest integer function. Notice how this is it's that step. It looks like, you're going up stairs, and then they tell you about the absolute value function. So same thing here. So it is asking you to graph. So go ahead and, practice, substitute points. What if I put a 0 here? What happens? Well, what's the absolute value of 0 is 0. 0 times 3, 0. 0, then -4 would be, there it is, -4. So again, practice creating a table, and then now look at the table here and see how they built the graph based on that. So you try to do it on your own in the space provided. That way you compare to see what the actual answers are. And then, of course, it's asking you to identify the domain and range. What I would suggest here is go ahead and, same thing, graph the functions, and then, of course, go back to the notes and see, well, how did I determine what the domain is, what the range is? Remember, the domain is all your X values, and then your range are your Y values. And then, of course, you've got more practice to get you more familiar with these, special type of functions. Of course, there is some word problems for you to try as well.